So here's an example. Let's balance this redox reaction in basic solution. First step, we will write the half reactions. For this particular one, it is a little challenging because we have silver with an oxidation state of 0 going to silver over here with an oxidation state of 1 plus. We know that because cyanide is a polyatomic ion with a charge of 1 minus, and there are 2 of them. So in order for us to have the total charge given here of 1 minus with 2 cyanides at 2 minus, the charge on this silver must be 1 plus. And if there is a charge, that is also its oxidation state. So silver is being oxidized. However, it does have as part of its product cyanide. So that means we could not just write silver going to this silver cyanide complex ion. We would need to include the cyanide in its half reaction. And then all we have left is just oxygen going to nothing in particular. But remember, we are going to be adding waters, hydrogen ions, and then eventually converting those hydrogen ions to hydroxide. So if you have something that contains oxygen or hydrogen without a partner on either side, it's okay because it will be added as you continue with the balancing process. You'll balance all the elements except for hydrogen and oxygen. One silver, one cyanide, 2 cyanides. Often if there are polyatomic ions, you can balance the polyatomic ions together, as one unit rather than balancing the elements individually, one carbon, 2 carbons, 1 nitrogen, 2 nitrogens. We could just say 1 cyanide, 2 cyanides. So we need to put a 2 here, and then we're not worrying about the oxygen yet. It's one of those elements we will balance later. So in step 3, we balance the oxygens with water. In this half reaction, there's no oxygen, so we don't need to add water. In this half reaction, we have 2 oxygens on the left-hand side, so we need 2 waters on the right-hand side. That now introduces hydrogen, so we need to balance the hydrogens with hydrogen ions. We have 2 times 2, 4 hydrogens on the right-hand side, so we need 4 hydrogen ions on the left-hand side. Then we will balance the charge with electrons. So if we look at this first half reaction, we have 2 times, this whole thing is 1 minus, so we have 2 minus. And then we have one of these whole things, which is 1 minus. So 2 minus, 1 minus, to make them equal, we need to add an electron to the right-hand side. And then down here we had 4 plus, and then nothing, so we needed a 4 minus over here with 4 electrons. Next step is to make the electrons equal for both of the half reactions. We have 4, we have 1, so we need to multiply that first reaction by 4, which will change the coefficients. Then step 7, add the reactions together. When we add the reactions together, we'll see that the electrons should cancel, and in this case, we do not have any common hydrogen ions or waters to either side, so none of the hydrogen ions or the waters will cancel, and we'll add the 2 half reactions directly. Now, you could verify this if you would like, and make sure that everything is balanced at this stage. Same number of silvers, 4 silvers, 4 silvers. Same number of cyanides, 8 cyanides, 4 times 2, 8 cyanides. Same number of hydrogens, 4 hydrogens, 4 hydrogens. 2 waters, 2 waters. The total charge is no charge, 8 minus, 4 plus, so that's 4 minus. No charge, 4 times minus, so 4 minus. Going through this process assures you that everything is okay at this step. Then, afterwards, because we are balancing it in basic solution, we will add the same number of hydroxides to both sides as we have hydrogen ions. So we have 4 hydrogen ions, we will add 4 hydroxides to both sides. The 4 hydrogen ions and the 4 hydroxides on the left-hand side will combine to form 4 waters. We will then see that we have 2 waters common to both sides, 2 waters here, 4 waters here, so we can cancel 2 waters from both sides. and then rewrite the balanced chemical reaction. Verifying again at this stage, both sides have an 8- charge, and we have the same number of atoms of each element on both sides. Because 4 moles of electrons were what was canceled, then 4 moles of electrons were transferred.